Hello, welcome to Econometrics by Richard. My name is Sumo Kobe Richard. We'll be talking about we've talked about the VAR model in the last class. So now we'll be talking about the issue of serial correlation, how to correct serial correlation and heteroscedasticity in VAR model. But I want to let you know that the issue of heteroscedasticity is not a serious issue when talking about VAR. The most important issue is serial correlations. So you don't have to pay more attention to the heteroscedasticity, but based on your own data set, because the data set I'm using is Nigerian data, so most times African data have these issues, but most if you're using other data sets or in other countries, maybe the data set might be more stable and it might not give you that issue. So I believe if you log your model, and then if you add the following steps I'm going to take using a different data set, your heteroscedasticity issue would have been solved before doing it. So this class will pay more attention to the serial correlation for this Nigerian data, because serial correlation is the most important thing you can use to run your estimation in VAR. So let's kick off from there. So what you're going to do, you go to estimate. We've actually said it is one lag interval for the intention. So we add what we're going to do. We are going to add those structural shock that I taught you in the past videos. You can go and check it if you missed it, to know how to get structural breaks and add it to your model. So you normally get it from your OLS, multiple break periods, can get the most break periods you have based on your model. So now you add the various data sets, the various structural shocks that we have in the model, and then the next one, you can add the OPR that you feel like can be affecting the model. So after doing this, the next thing is that you have to difference those variables, because we saw that all of them were stationary at I1. So difference them. You difference them so that you can know where the issue is coming from. You difference the model. So don't pay more attention. What you pay more attention to is the AR, the instability test, the inverse root graph, and the serial correlation test. So when you get that, you can be able to run your impulse response functions. So this is it. You can be able to watch the video anytime you want. You can watch back to back. It's after differencing it. Sorry, my keyboard is messy. Sorry. So this is it. So you click on OK. So this is your estimation. We know the coefficients are the one you interpret in your results. So you go to view, check the AR root graph, because that's the most, you see all of them are within the cycle, which means the model is really stable. And then we'll check for our serial correlation, autocorrelation LM test. We said is 1. And then we'll click on OK. You can see we still have the issue of serial correlation. So we'll go to check for the white heteroscale, which I thought is not really important, but you can still check it. You can see there's the issue of heteroscedasticity. So you go to estimate. What you do, you increase your lag interval. When we checked our lag length criteria, we saw that it is both lag 1 and lag 2. So now we've tested for lag 1, we saw that we have an issue. But I believe if you different your data set and add most in your own difference your data set, you have done and add some structural breaks with some exogenous variable that you feel that can be affecting the model, I think your model will be okay from heteroscedasticity and serial correlation. But if you still have this issue, you increase your lag interval. When you increase your lag interval, you click on OK, then you go on view, then you click on, let's check because this is very important, AI root graph. You can see this is even still wonderful. You can see it's still within the cycle. And then we go and click on the serial correlation. We change it to 2. you can see the model is actually very, very good. So we have to accept the null hypothesis that there is no serial correlation in this model. And I told you the heteroscedasticity is not really important. When you get this and you see that your model is stable, I think you're good to go. So in our next class, we'll be doing we'll do the impulse response function, the variance decomposition, and the historical decomposition, and then I will interpret it for you. So please like and share and subscribe to my YouTube channel. Thank you for watching.